Hello everyone, today we're going over 2.6. We left only like some things there. So first of all, let me remind you for the vertical stretching and shrinking of graphs. If I have to graph the function like this, y equals c times f of x, and this c is outside the function. Outside the function, I mean, is outside the parentheses of the function. So you have to know the graph of this function is shrinking or stretching depending in the value of c. So if this c is greater than 1, I mean like 2, 3, 4, wherever, so the function will be like stretching of the original function y equal f of x. And the stretching will be like vertically again because the c is outside the function. If the c is between 0 and 1, so we're going to do shrinking of the function again vertically. The horizontal For the horizontal shrinking and stretching, if we need to graph the function y equal f of c times x, the c is inside the parentheses as we see. Here the c, the number is inside the parentheses multiplying by a variable x or y or any like variable. So if this c is between 0 and 1, so we're going to graph the original function f of x without the c. We're going to do stretching for the original function horizontally. And if this c is greater than 1, like 2, 3, 4, we're going to do shrinking for the original function. So as we see, number 1 and 2 here is the opposite for 1 and 2. For here, if c is greater than 1, we do stretching. But about here, if c is greater than 1, we do shrinking. And the same thing, if c here between 0 and 1, we do shrinking. But here, if c between 0 and 1, we do stretching. Okay, so let me give you example. Last time, I think I gave example, but I did not finish all. Like I gave like one example, but we could not finish the examples. So suppose my example like this. Example here, graph. So in this example, I'm giving the original function. So by using the function, the graph of the original function O of x, the original function equal x squared. Now the question is sketch each of the following. Sketch each of the following. So number 1, have 1 g of x equal 3 times x squared. Second one is h of x equal 1 over 3 x squared, and the last one 3 is d of x equal 2x squared. So here I have the original function is x squared. So my original function is square root of x. Here I have x squared. And I need to graph the function g of x equal 3x squared. And here I have 1 over 3x squared. And here I have 2x squared. So for the first one, I think I give you the idea how I can graph the first one. So my original function is O of x equal x squared. I have to modify it for this function to make it similar to this one. Then I can graph the function g of x. What I should to do here? Anyone has idea? So my original function is O of x equal x squared. What I should to do to make the function, or what I have to modify for this function to make it similar to this one, 3x squared. What I have to do, like some operation like multiplication, subtraction, or substitute to make the function this one, x squared equal 3x squared. Any idea from last time? So I have to multiply both sides by 3, multiply this side by 3. So when we multiply the both sides, I would get 3ox, 3o of x equal 3x squared. Now 3x squared is similar to this function. See this function and this function, both of them are the same. So I can write here now, because this one is equal to this one and this one is equal to the g of x. So 3ox equal g of x. Okay, now I can rewrite these things as g of x, this one, equal 3 times o of x. This is o, the function o of x. Now this is mean, if I go to back to the vertical stretching and shrinking, I see first of all the number 3 is outside the function. The number 3 here is outside the function. I mean, for outside, it's outside the parentheses of o of x. It is outside of the parentheses of the function o of x. So outside means vertically. This is the first step. So outside means we have to graph vertically like this, vertical, not horizontal, vertical. And the 3, we have to check the 3. Is it the 3 greater than 1 or is between 0 and 1? So you go back to the rules. If this c is greater than 1, we have to do this one, these things. If this c is between 0 and 1, we have to do shrinking, these things. So the 3 here is greater than 1. And also the 3 is outside, So to graph something like this, you have to put these 2 rules. The first one, put in the black. This is the first rule. This is the second rule. The 3 is outside mean we have to do vertically. So this is mean vertically. And also the 3 is greater than 1. Here we have to do stretching of the graph. Stretching. Stretch. Okay, let's do it now. So my original function is O of x, this one, square root of x. We have to first graph this one. Then we have to do vertically stretching. Okay, let's do it. Here's my Cartesian plane. This is the y-axis. This is the x-axis. My original function is O of x equal x squared. So this is, how is the graph for this one? What is the graph of O of x equal x squared? Do you know the graph of this function? Is a parabola, yes. It looks like a parabola, like a cup. This is the graph of the function. This is O of x. So first of all, you have to graph the function O of x. So this is O of x. This is the first step. Then the second step is to graph the function g of x equal 3o of x. So now I'm going to graph the g of x equal 3o of x. 3o of x, we have to do vertically stretching for the function for the function o of x. For the original function, we have to do vertically stretching. So like this. Vertically mean something like this, up and down, up, down. Here the same things, down, up. This is vertically. And stretching mean should be far from the x-axis. Will be far from x-axis. Something like this. So the graphs will be like this. This is far. Like closing to the y-axis. Like it will be like far from x-axis, like this, far. So this is mean stretching. So here, this is g, you have to label it, g of x. And the black, you should write o of x. Any question? Is it clear for this? Okay, let's do number 2 if it's clear. Do you have any question? Any of you has a question for the first one? Is that considered shrinking? No, this is stretching. Shrinking, if the question is shrinking, will be like you have to push the function, the black one. When you push, this is mean will be like, and vertically, if the question is shrinking vertically, so vertically like this arrows, up and down, and shrinking mean we have to push for the function, the black one, to the x-axis. So it's going to be like this. We push to this. We push this until we get the blue curve. But stretching mean we have to make it like far from the x-axis, like this. Okay. So this is here, the red one now is called stretching. Stretching of the function O of x. What does the 3 represent? This 3, again, if the 3 is outside, see the 3, you have to know, you have to write 3 is outside, mean vertically. This is the first step. And when you see 3 is greater than 1, this is mean you go back to the rules. If c is greater than 1 means we have to do stretch for the original function. We have to do stretch to the original function. Stretch to the graph of, this is mean the original function. The original function here is O of x equal x squared, the parabola. In general, if you need to know what you should to do, you have to write this. This is very important. By this, you will not get confused for a graphing function like this. This is very important. They will help you to graph the function. The C and is outside or inside. Okay, Eric? Now to graph the second one, h of x equal 1 over 3x squared.
Wait, sorry, I have a question.
Yes. Go ahead.
So, you know the three before the original function. When you said stretch, are you supposed to like move the graph up?
If it's vertically, yes, goes up like this. Stretch, you it will be like up. But shrink means the curve will be go down. Like you push to the curve. When you push to the curve, suppose like you push it down to the ground. This is the ground. When you push to the curve, the black one to the ground, will be something like this, like this. Understand? This mean shrink.
Oh, that makes
Okay?
sense. So wait, the red one. So you moved it three
Yeah,
times closer?
I mean the red one is stretching, not shrinking.
Yeah, that's what I'm saying. Like,
The
did you
red
move
one
like
here,
three times
yeah,
closer or?
stre- is not three. Yes, is yeah, exactly. Is like three times up. Like this point, for example, is one, and this point is one here. Like this point, for example. So now the a new point will be like 1 and 3. You understand? Like it will be
Wait,
goes up.
I
You
understand now.
understand?
I understand now. Thank
Now, yeah. So if the point here, let me like if this point, for example, is one, and this point is one, this point actually is 1 and 1 for the original function. Now the new point will be like 1 and 3. So here one, and like around here, this point. This is 3, this is 1. Now 1 and 3. This point is 1 and 3, 1 comma 3. All the points the same things. Here we have 2 and 4. Now will be like 2 and 4 times 3, like 2 and 12. So 2 and 12 would be like far up. Okay. Now for graphing the second one, h of x equal 1 over 3x. H of x equal 1 over 3x squared. Now, first of all, you have to ask yourself, before you ask, you have to change this function to the original function O of x. Now, my function, original function O of x equal x squared. What we should to do here for this function to make it similar to this one. So the x-axis is going to have the same number. Yes, the same number, like 1, 2, 3, 4, but the y-axis, we're going to change the value for the y. So here, for example, 1 and 1, here will be like 1 and 3. If I have the point 2 and 4, for example, it will be like 2 and 12 in the red one. Understand? If the black curve will be like 2 and 4, the curve, the black one will pass the point 2 and 4. But for the red one, we'll be passing 2 and 12 because 4 times 3 is 12. 2 and 12. Okay, Mayasha. Now for the second one, I have h of x equal 1 over 3x squared. Uh, 1 over 3x squared. Okay, so what we should to do, yeah, multiplying by 1 over 3, exactly. If I multiply both sides, multiply this by 1 over 3, and to multiply this by 1 over 3, I'm gonna get O of x, 1 over 3, O of x equal 1 over 3 x squared. Now, look to this function and look to this. They are the same. This is mean I can write here equal to the function h of x. Make sense? Now, you rewrite these things as h of x equal 1 over 3 O of x. Okay, now you should to ask yourself, is the number outside the parentheses or inside the parentheses? 1 over 3 is outside or inside the parentheses?
Outside.
Outside, exactly. So it's outside the parentheses. This is mean, is it a vertically or horizontally? We have to do shrinking or stretching. If it's outside, is it vertically or horizontally?
I think it's vertically.
Vertically, look, the number here, if you go back to the rules, the C is outside the function. This is mean vertically, see, vertical. But if the number inside the parentheses mean horizontal, see the horizontal? Now, my number 1 over 3 is outside the parentheses, so vertically. So I should write here vertically, up and down. Now, the 1 over 3 is between 0 and 1, or is it greater than 1? Is it greater than 1 or between 0 and 1? Between, exactly. So 1 over 3 is a number between 0 and 1. So this is between 0 and 1. So I have vertically, and the number is between 0 and 1. You have to go back to the rules. Vertically, and the C between 0 and 1, I have to do shrinking for the original function. Shrinking to the graph of y equal f of x. This is mean here the original function. My original function in the question is x squared. O of x equal x squared. So I have to do shrinking to my original function. Okay, let's do it. So here means shrinking. Again, the number, because the voice is not clear. Okay, listen, Sahil Ahmed. If the number is, you have to ask yourself, is 1 over 3 greater than 1 or between 0 and 1? So some of you said the 1 over 3 is between 0 and 1. 0 and 1, and the number is vertically, and 0 and 1. Go back to the rule. You see 0 and 1 and vertically mean we have to do shrinking to the original function. My original function in this question is O of x equal x squared, the parabola. So we have to do shrinking to the parabola. Okay, so let me graph the parabola function. I mean the original function. Here is the graph of the parabola function of x squared equal. This is the function I need. This is the function O of x equal x squared. Okay, this is my original function O of x equal x squared. Okay, now I need to graph the function h of x. My goal now, graphing the function g h of x equal h of x equal 1 over 3 x squared, and this is equal 1 over 3 O of x, as I see here. H of x equal 1 over 3 O of x. So, or I can say h of x equal 1 over 3 O of x. So this is mean here I have to do vertically shrinking. Vertically shrinking mean I have to do the vertically like this, up and down. Here up and down, it depends if it's the graphing down. So shrinking mean we have to push to this function, to the ground. The ground is my x-axis. So the graph will be like this. This is the graph of h of x. Everything will be like closing to the x-axis. Any question? Any question for this?
Yes, I have a question. Is it
Yes.
always that the both equations gonna be equal to each other, or are they ever gonna be different?
Because the question told me by using the graph of O of x equal x square, so my original function is x square. I have a graph, first of all, the O of x equal x square, then I have to do the vertical and horizontal stretching and shrinking. And I don't know if I did not understand exactly your question, but all of them are different. For the first one, we multiply by 3. So for the first one was vertically stretching. For the second one is vertically shrinking. And for the third one, we're going to do it right now. So vertically stretching for the x square was like the red one. You see the red one? And for the second one is vertically and shrinking. We do it like the green curve. See the green curve? For the third one, we're going to do it right now. Here I get the question. So when it's outside, it does not affect the x-axis? It does not. No, will not affect on the x-axis, Eric. The same point in the x-axis. For example, if this point in the curve, the black curve, like I said in the red one, if it's vertically horizontal, Eric, if it's vertically, will not affect in the x-axis. But if it's horizontally, yes, will affect. So for example, I told you if this point is 1 and 1, so in the red curve will be 1 and 3. Same things for the black. If the point, because the black curve passing the point 2, 4, so 2, 4 in the black one, in the red one will be 2, 4 times 3, 12, 2 and 12. You understand? The same things from the left side, 1 and 1, minus 1 and 1. In the red one, in the red curve will be minus 1 and 3. Now for this one, the same things. The curve passing the point 1 and 1. So for the green one will passing the point 1, 1 over 3. Okay. So if the curve passing the point 1 and 1, for the curve, the green one will pass 1, 1 over 3. Let's do the third one, d of x equal to x squared. D of x equal to x, everything squared. First of all, like I said before, you have to work in the original function of x equal x squared. Or this is equal actually x to the power 2. Both of them are the same. Now, how can I modify this function, the original one, to make it exactly the same as 2x to the power 2? What I have to do for the x here, or what I have to do for all this function to make it exactly equal to x to the power 2 times 2. If I multiply both sides by 2 like this and multiply this by 2, I will get 2o of x, 2o of x equal 2 times x squared, and this is equal to x squared, and this is not the same as
You have to
2x
multiply
everything
inside.
squared. Yes, exactly. I have to multiply inside, or I have to substitute inside. So if I
Professor?
substitute inside,
So when
yes,
there's parentheses, we can always think of substituting inside, and when there's no parentheses, we don't have to think about, we multiply it outside, right?
exactly. Or when you see the exponent, you see the exponent over for the number 2, you have to multiply, or you have to substitute inside. When you see exponent for the number, like everything raised to the exponent like this, for like this example, this is mean you have to substitute, or you have to multiply inside. So here I can substitute a plug instead of x, 2 of x. So I'm gonna get, when I plug the 2x inside, I get O of 2x equal 2x everything square. Now look, this is the same as this, and this equal d of x. So this is equal d of x. Okay, now I can rewrite these things as d of x equal O of 2 of x. Okay, first of all, is the number inside or outside? The number
Inside.
is inside it's inside, exactly. So the number 2 is inside. So this is mean if it's inside, it's horizontally. For the second things, is the number 2 is greater than 1 or between 0 and 1? Is it between 0 and 1 or greater than 1? Greater than 1, exactly. So number 2, the number of 2 is greater than 1. So this is mean, let me go back to the rule, horizontally and greater than 1, horizontally here, horizontally and greater than 1, this is mean we have to do shrinking horizontally, shrinking to the curve, to the original function and horizontally. So we have to graph the original function O of x, and then we have to do shrinking. So let's do it.
Can you go back for a second?
Yes, I will do it. Hold on. Okay, here.
Got it. Thank you.
You're welcome. Here's the graph. So this is O of x, the origin function. Okay, now let's doing shrinking and horizontally shrinking. Shrinking horizontally. So horizontally mean the would be something like this. This is horizontally. And also shrinking mean we have to push it to the x to the y axis, like you have to push this curve inside. So it's going to be something like this. This is the curve of the function. Be like close to the y-axis. Shrinking mean we have to push to the function. Okay.
So wait, isn't this the same exact thing we did for the vertical shrinking?
Yes, vertical shrinking. Yes, it's look like this, like the vertical shrinking. Yes, no, vertical stretching, like this.
Oh yeah, that makes sense.
Yeah. So it's similar to the vertical stretching. This is here d of x. Okay. Any other questions? Is it clear? We don't need it. Okay. So this here d of x, and this is the black one. So when it's vertical or horizontal and it has to shrink, it all be this. It will be the same. It depends on the function. In this function, it was the same for the O of x for the parabola, but some function is not the same. Okay, this one is shrinking. Yes, it is shrinking horizontally, left and right, left and right. We push to the black one to the inside, close to the y-axis. Okay, so any other questions? If you need to practice more question for this, just do the website question. You will see a lot of question for graphing something like this. Uh, also, we have to know the even and the odd function, and even and odd functions or function. So we have to know if the function is even. We have to define if the function is even or it's odd. So let me define first of all the mean of even function and odd function. So suppose I have a function f be a function. Suppose I have f be a function. We call it f. So f is even. We said f is even function if f of x equal f of minus x f of x. If we plug if this rule is defined, satisfy for the function, we said the function f is even for all x in the domain. For all x in the domain. Now, second one, we said f is odd function if satisfy f is odd function if f of x equal minus times f of minus x for all x in the domain. So this is the definition. We have to check if the question asks you check if the function is even or odd. You have to check this rules. Okay, let me give you example for this. So my example, determine which of the following of the functions is even or odd or neither. Even nor odd. So for the first one, f of x equal x cubed plus x. And for the second one, h of x equal 2x minus x squared.
I'm sorry to interrupt. I think there was a mistake in the second, what do you call it? The second formula.
This one?
Yeah, the
This?
the
Yeah,
f.
maybe in high school you...
Wait, it was
Yeah, go ahead.
negative f of x or negative f of negative x.
Yes, in high school you learn minus f of x equal f of minus x, like this. But this is the same as this. Here, divide both sides by -1. you will get f of x equal what? Minus f of x. F of minus x, sorry. So this is the same.
Okay.
This and this are the same exactly.
Okay, thank you.
No problem. So here determine which of the function is even or odd or neither even nor odd. Here f of x equal x cubed plus x. Here h of x equal 2x minus x squared. So for the first one, I'm going to do it by myself. For the second one, I will let one of you to do it. So for the first one, f of x equal x to the power 3 plus x. Now to check this function is even or odd is not by we do summation for the exponent. We don't have to say 3 plus 1 is 4, so the 4 is even. This is completely wrong. Is even number, so it's even function. This is wrong. This is not correct. It's not by adding the exponent. So the way is direct. You have to check by this rules. You have to ask yourself, is f of x, first of all, you have to write f of x like this. Then you have to write f of minus x. You plug the minus inside the function. So when I plug the minus inside this function, I get minus x to the power 3 plus minus x. Actually, I plug the minus inside the function here. Or I substitute the minus x inside the function. So now minus x raised to the power 3 is the same as the minus equal, this is equal, minus x to the power 3. And here plus minus x is the same as minus x. This is the first step. Now second step, you have to write minus f of minus x. This is mean we have to multiply this function here, the second function, by negative. So you have to put like this minus, and you copy these things inside the parentheses. Minus x cubed minus x. Then you have to distribute the minus inside the parentheses like this. You will get minus times minus is positive. So positive x cubed, and minus times minus is positive x. Now, to check this function, number one, is even or odd, you have to compare this one. You have to check, you have to ask yourself, is this one equal to this one? And you have to ask yourself, is this one equal to this one? Or if I want to rewrite it again, you have to ask yourself, is f of x equal to f of minus x? Is f of x equal f of minus x? So to check that, f of x equal x cubed plus x. And f of minus x is here, minus x cubed minus x. Is this equal to this? No, it's not equal. So the answer is no. This is mean the function is not even. So no, it is not even. Now to check is odd, you have to ask yourself, is f of x equal to the minus f of x? Is f of x equal to the minus f of x? What is f of x? This one. And what is minus f of x? This one. Is this one equal to this one? Is x cubed plus x equal to x cubed plus x? Yes. So the function is odd. Is it clear? Is it clear what I said here? How to check the function is even or odd? Can you please explain it again? Okay. So first of all, for the first function here, you have to write f of x. The f of x is the same like the original function, x to the power 3 plus x. Now you have to write f of minus x. F of minus x mean we have to plug the minus inside the function. This is mean equal minus x to the power 3 plus minus x. Simplify these things here. This is equal minus x to the power 3 because minus x times minus x times minus x is minus x to the power 3. Look, I'm going to do it here. Minus x times minus x times minus x equal minus times minus is positive times minus is negative, and x times x times x is x to the power 3. So this is equal minus x to the power 3. And here we have plus minus x would be minus x. So for the second one, it would be like minus x cubed minus x. Now we have to write the other function is minus f of minus x. This is mean we have to multiply the second one by negative. So we have to put the negative, open parentheses, copy this thing, and put it inside the parentheses. Now, you have to distribute the minus inside the parentheses. So to distribute the minus inside the parentheses, you will get minus times minus is positive x cubed, minus times minus is positive x. So the answer is x cubed plus x. So you have to go back to the rules. The rules said if f is even if satisfy this condition. The condition is f of x equal f minus x. Here is my f of x. Here is my f of minus x. You ask yourself, is the red the same as the green? Is x cubed plus x is the same as minus x cubed minus x? No, it's not the same. So it's not even. Now to check the second one, you have to ask yourself, is f of x equal minus f of minus x? Is the red one is the same as the blue one? As we see here, x cubed plus x, and here we have x cubed plus x, and this is they are equal. They are equal. This is mean the function is odd. So I have to say the function is odd. Is it clear? You're welcome. Now for the second one, who will do the second one? H of x. So f of x equal h, h of x equal h of x equal 2x minus x squared. Okay, who will do this one? Who will check if this function is even, odd, or neither? Anyone?
Okay, so
First,
first of all, you have to find h of negative x,
h of negative x,
which is going to be 2 times negative x.
Okay.
minus negative x
Square.
squared.
Okay. Now this is equal
Negative 2x
negative 2x. Okay.
minus
Minus.
x squared.
Okay. Perfect. Nice. Now for the second step.
Okay, so now we gotta find negative h of negative x.
Okay. Perfect.
And since
Equal.
we already found it, now we just have to negate
Multiple.
the function we just found. So
Okay.
negative 2x minus x.
Negative. Okay. Then
Okay, so now we have 2x, positive 2x
positive 2x. We have to distribute. Okay.
plus
Plus.
x squared.
Okay. Nice. Now we have to check.
Mm-hmm.
Is h of x equal to h of minus x? I will use the black color. My question is h of x equal to h of minus x? Is this thing here equal to this?
No.
No. So the function is not even. Is not even. Now the second question, is h of x, the first function, equal to minus h of minus x? Is
No.
this one yes or no?
No.
No, exactly. So he will have 2x minus x squared. He will have 2x plus, see the plus? This is the different, plus x squared. So no, is not odd. So the function is not even, is not odd. So it's neither even nor odd. So the function is neither even nor odd. So it's not even, is not odd, the both sign. Any question for this example? Here, number 2. Is it clear for all of you? Actually, this is a large section, and I think is hard too. But if you review what everything I said in the class, and you solve the homework, the web sign, it will be like easy sections, easy section for you. So just you have to solve the homeworks in web sign and do review for the example that we did during this section. So the section is finished. Now let's go to the 2.7 combining functions. 2.7 combining functions. So first of all, we have to know if let I have two functions. Let I have the function, for example, f, and I have the second function g, b a functions, b a function. So suppose f is a function and g also a function. So all of them function with domain a and b respectively. Respectively mean the domain for the function a is a, the domain for the function f is a, and the domain for the function b g is b. For g, the domain is b, and for f, the domain is a. Now I can define four things. Number one, the sum of these two functions, the sum of f plus g for the function x is the same as f of x plus g of x. This is for the first one. For the second one, number 2, the difference between these two functions, so the difference as f minus g of x is equal f of x minus g of x. This is for the second function. For the third function, the product, if I have f times g of x is the same as f of x times g of x. And the last function is number 4. Number 4 said if I the quotient, so f quotient g of x equal f of x over g of x. First one blue color, second one red, third one green, and this one is pink. So I defined the function as the sum of these two functions and the difference of these two functions, also the quotient between these two functions, and here also this is equal f of x over g of x. F of x over g of x, and this is equal actually again, this equal f of x times 1 over g of x times 1 over g of x times 1 over g of x. So also we should to know important things is the domain. Here is the domain. The domain of this function is the intersection between A intersect B. The domain for the second function is the same as A intersect B. The domain for the third function is the domain of the function f intersect the domain of the function g is b. For the last one, the difference here, the domain is the same as x. It belongs to the intersect A intersect b, but we have to remove the zeros for the function g of x, except the 0 of g of x not equal 0. This is mean the same as the domain like before, but we have to remove the 0 for the second function. The function is in the denominator. Okay, let me give you example for this. So example 1. So the example, suppose I have the function let f of x equal 1 over x minus 3, and also suppose g of x equal square root of x. So again, suppose my function f x equal 1 over x minus 3, and my function g of x equal the square root of x. Find f plus g of x, and it is its domain. And find the domain for the function here, and the domain.
So is it gonna be according to the formula, is it is it gonna be 1 over x minus 3 equals square root of x by any chance?
Again, what you said?
So you know how
What,
the first
what is the definition? What is the definition for this?
don't you have to set them equal to each
What
other
is the
because
definition?
okay, never mind.
How, what you said exactly? How I can like solve this f plus g of x? What you said?
My question is, according to rule number 1, f plus g times x equals f of x plus g of x.
Okay.
So the example that you gave, does that mean that 1 over x minus 3 is equal to the square root of x plus the square root of x?
This is
Something like that. Do you add or you put an equal sign? I just want to know.
Again, you said 1 over x minus 3 equal x square.
Square root of x.
Oh, square root of x equal the
Is it
square root of x. Like
is
this.
that how you do it, or do you add it?
The question is find f plus g. Find the adding between the function f of x and g of x. It's not asking to find is equal the x, like the square root of x.
So it's same thing as 1 over x minus 3 plus square root of x, right?
Exactly.
Right, yeah,
Exactly.
that's what I was just a little confused. Thank you.
No problem. So f plus g, all of this in parentheses is the same as the first function plus the second function. So the first function is given here. This is my first function. You have to put down 1 over x minus 3. And the plus, what is the second function? This one. You have to add this function. And you can keep it the same like this. You don't have to do anything. So this is the adding between these two functions. Now find the domain for the function. What is the domain of f plus g everything to the x? The domain, as I see here, is the same as the, yes, Ayman? What is the domain? Is
A
the
and B.
yes, A and B is the intersection between the first domain for the first function and the domain for the second function. Is the intersection between the domains such that the domain for the first function and the domain for the second function. So this is like exactly the same as the first section for this book. And I give example before for this to find the domain. I mean the intersection between two interval. So what is, first of all, what is the domain? The domain for the function for 1 over x minus 3. What's the domain for this function?
X cannot equal 3.
X such that x equal 3.
No, X. She said. I
No,
think
like
she
it
said
X
X
cannot
cannot.
equal 3.
Not equal 3. This is correct. So this is the same as the domain for this function. All numbers, all real numbers except 3. Why? Because if I plug the 3 in the denominator, I will get 1 over 0, and 1 over 0 is undefined. Now, what is the domain? The domain for, here is the domain for for square root of x. What is the domain for the square root of x?
I want to
Any
say x greater than 0. Anything greater than 0. It cannot be less than 0 because that's going to be negative, and you don't want negative under the
Yes.
square
What
root.
about the zero? What about the zero itself?
yeah, you can include 0. So anything
Oh, yeah, you
less than 0, less than or equal 0, I think.
Yes.
greater than
Everything
or equal.
greater than or equal zero, like this.
Oh,
All
sorry.
numbers
Yes,
greater
greater.
than or equal zero. Okay. So for the first function here, the domain I can modify. I can put it as on the real line. I can distribute this one as in the real line. So this here, the domain, it will be like everything on the real line, but except the number 0. So suppose this is except the number 3. So suppose this is my 0, this is 1, this is 2, and this is 3, and it's open circle. So actually the domain will be everything, 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 except 3. This is the domain. Here is the 3. So the domain would be like all numbers except the number 3, except the 3. So it would be like everything except the 3. Now for the second one, if I want to show it as in the real line, it will be like all numbers greater than 0. All numbers greater than 0. So all numbers greater than 0 will like I start at 0, but I have to put the 0 exactly like the same here. So the 0 here is here, so it's supposed to be the 0 here below each other exactly. So here is 1, here is 2, and here is 2, and here is 3. So 1, 2, 3. So the domain for the second one, everything starting from the 0 and goes up. So everything starting from the 0 and goes up. So start at 0 like this and goes up, and everything including like this. Now, what is the intersection between the both of the domains? What is the common value between the both of the lines?
0, 1, 2, those numbers.
Yes, but what about the 3?
We only included in one of no.
The 1 is including. What about the 3?
I think you can put an open circle. I think that counts, yeah.
What about also the -1 will be included? The -1. So the domain between for these things, it's supposed to be the intersection between the domain of this and the domain of this. So what is the intersection between the both of the domains? As I know before, the intersection is supposed to be like the common value between this line and this line. So the 0, as I see here, the 0 is including for both line. The 1, yes, and the numbers between 0 and 1 also, all of them, yes. 1, 2, 3, all these numbers are included, but the accepting things is the 3. The 3 is not included, and after that, after I jump for the number 3, all the numbers will be included, right? So I can say here, like I have to put the 0 here, 0, here 1, 2, 3, and 4, and all numbers 5, for example. So the domain should be all numbers starting at 0. The 0 is including, and all numbers here except the 3. 3 is not including. because it's not a common between the both of for the both of the lines. So here open circle. So here is open circle like this. And all this value are including so the domain is the intersection between the both of the domains. So the domain is x such that x greater than 0 and including the 0, and in the same time x not equal 3. All numbers greater than 0 but except number 3.
Professor,
Yes.
these examples, they're going to be a little harder in the exam, right? What I saw in the last exam is in the lectures, the questions are pretty understandable, and but the exam is with the same concept, yes, but it's pretty difficult. Because stuff like these, I think if they don't, if they get a little difficult, the things get a little messed up. I was just wondering if you just show us a little more examples with like harder numbers and harder.
So here is the domain is x such that x is greater than or equal 0 and x not equal 3. This is the domain. Any question for this?
No question.
What about the other student is good?
Yes,
Okay.
no questions.
Okay, so now let's go to the composition of functions. Here, composition of functions. So here I have to know, we have two functions, f and g. The composition function, the composite functions, f circle g is defined as f circle g like this, like f circle g is defined as f circle g is equal of x equal f open parentheses g of x. Okay, so f circle g of x is equal f open parentheses g of x. Okay, so I give you an example for this, how we can applying this formula. Example, let f of x equal the function for x minus 2, and let g of x equal 5 minus x squared.
Professor,
Yes, go ahead.
what is that in between f and g in the first? Is that as
This is circle or composite.
oh
You
okay
can
okay
f circle g of x equal f of g of x. Again, f circle g of x equal f g of x. So my question here, find f circle g of x, and at the same time and G circle f of x. Okay, to do the first one, f circle g of x is the same as f of g of x. Now, let me do the first one. So this is mean we have to plug the g of x inside the function f. So you have to write it like f, open parentheses, g of x. You have to copy g of x inside the function. 5 minus x squared. You have to plug the g of x between the parentheses. The g of x is this one. You have to put this one here.
And then you have to multiply by 4x minus 2 again, or no?
Exactly. No, it's not multiply. You have to plug these things, this piece, inside this function. You
Okay.
have to like 4
Okay.
open parentheses 5 minus x squared minus 2. This is actually one piece. This is a one piece. You have to put it inside the x. Okay, so this is actually one piece. You have to put it inside the value of x. So you will get 4 times this piece minus 2. Why I did that? Because the function f, I have to go back to the function f, this function. 4x minus 2 will be like 4 times x minus x, 5 minus x squared minus 2. Now you have to distribute the 4 inside the parentheses. You will get 4 times 5. What is 4 times 5? Is 20. 4 times 5 is 20. And 4 times minus x squared is?
Minus 4x squared.
Exactly, minus 4x squared. And the remaining things is minus 2. Now let me simplify it.
It's going to be negative 4x squared plus 18.
Exactly, correct. Plus 18. Negative 4x squared plus 18. Now let's do the second one. G, the second one is G circle f of x. So for the number one is done. This done. Second one. G circle f of x. This is equal G of what? F of x, like this. By using the rule. This is my rule. This is my rule. G circle f is equal G open parentheses f of x. Now, plug the function f of x here. What I get? G of what? What is f of x?
You get g of 4x minus 2.
4x minus 2. This is correct. 4x minus 2. Now plug this piece inside the function g. What I get? This here. This is one piece. Put it here inside. Substitute it inside. I will get 5 minus what?
5 minus x squared.
But x squared, I have to plug these things inside the x squared.
Right. 4x minus 2.
4x minus 2. Correct. Square. Okay.
Oh, so we just simply
What is the value? Yes, go ahead.
we just simply use the formula and just plug in the two different functions 2 different times, right?
Yes, you plug, exactly. You plug it 2 times. What is
Okay.
the 4x minus 2? This square.
Is it
How?
is it 16 plus 16x squared plus 8 plus minus 8 plus 4, I think?
Yes, is the first term square. The first term square is 16 x square minus, you put minus, you multiply the 2 with the first term with the second term. Can you do it? Who will do it?
16x
2 times 4, yes, 16x, exactly. Then
plus 4.
plus 4, yes. The first term square plus the second one square minus 2 times the first term times the second term. I get minus 16. Now, so this is equal 5 minus this here, 16x square minus 16x plus 4. Now you have to distribute the minus inside the parentheses. What are you gonna get? Minus 16x square, so I will get here equal 5 minus 16x square minus 16x square minus plus 16x, like Eric said, minus 4. Let me check. Minus 16 plus 16 minus 4. Correct. Thank you, Mark. Eric. Now let's simplify this
Wait,
thing.
isn't it plus 4?
Here I have 5 because we have negative, we have plus 4, we
Okay.
will be negative. Yeah. So 5, now 5 minus 4 is, so I will get minus 16x squared plus 16x. Here I have minus 4 plus 5. What is it?
Plus 1.
Plus 1, exactly. Plus 1. So my question now is G circle f of x the same as f circle g of x?
No.
No, it's not the same. Exactly. Thank you so much. It's not the same. Look, g of x, g circle f, g circle f here is minus 16. So g circle f of x is the same as minus 16 x squared plus 16 x plus 1, and f circle g of x from back is minus 4x squared plus 18, minus 4x squared plus 18. So this here, this function is not the same as this function, so the answer is no. So g circle f of x is not the same as f circle g of
Professor?
x. Yes.
Sometimes the expressions turn out a little similar, and they can be sometimes tricky. So can we plug in numbers to see whether they're equal or no?
Yes, you can sometimes plug numbers like 1 or 2 sometimes. But I said here, Iman, this is in general. I said in general for all functions, this is not equal to this. I mean, this is not equal to this. Next time, I will continue giving another example by using numbers, it's not by using variable x. So next time, I will give you another example by using number instead of x. Okay, Iman?
Yes, Professor.
I will see you next week. Have a good day, everyone. Any question before we leave? Everything is clear?
Yes, thank you, Professor.
Okay. I'll see you next week. Have a good day.
Professor, I had a question about the midterm.
Okay, but hold on one second. What about this class? Anyone has a question? No questions? Okay, let's stop recording.
Professor, now I have no questions right now, but when I'll start doing my web assign, can I ask you a question that time? Because if I get confused. So,
Yeah, no problem.
okay,
Yes, no
yeah.
problem.
Because
Yeah,
right
you
now
can
there
ask
is
me.
no question, it's
Yeah.
clear, but I don't know what will happen when I start doing the web assign
No
exam.
problem. If you have questions from Hoba sign next time, you can tell me what is your question. We can solve it together before
Okay.
the class start.
Okay, yeah,
Okay.
that's good. Thank you so much, Professor. Have a good
No
day.
problem. You too. Have a
Bye.
good day.